Good morning, students. In the last lectures, we can complete the chapter number 2, the linear applications of op-amp, and we can see the different type of controllers, P type, I type, D type, and the combination of these PI and PID type controllers. Which one is control our op-amps or circuits, and then after we can see the wind bridge oscillators. There are the two types of oscillators, phase shifting oscillators and phase shift, and then after the oscillator types controllers. Now start with the new chapters, non-linear application of op-amp. So non-linear applications of the op-amp is the feedback is provided using the non-linear element like the diode, transistor, and etc. So in some linear applications the op-amp is used in the open loop mode. So the various non-linear applications of the op-amp includes the comparators, zero crossing detectors, Schmitt triggering, then precision rectifiers, and peak detectors. So today's topic is inverting, non-inverting configurations and applications of the comparators. So our first question is, what is comparator? So comparator is a circuit which compares the signal voltage applied at the one input of the op-amp with the non-referred the voltage at the other inputs and produce either a high or low output voltage depending on which input is highest. So that the comparator is nothing, the voltage comparator has the same terminal structures of the op-amp component of the 5 terminals. So first one is the positive terminal, then negative input terminals, positive side power supplies, negative side power supplies, output terminals. So the comparator is for comparing the analog voltage. Its the output is either low or high. So it produces the output voltage which is either positive saturation voltage or negative saturation voltage. As comparator output has the two voltage lever, either a high or low. So it is not linearly proportional to the input voltage. So the difference in the voltage between their reference value and the voltage supplied at other input pin is amplified, resulting in the high or low input. So they have the two main conditions. If the positive input pin potentials is greater than the negative pin potentials, the output is high, and the negative input pin potentials is greater than the positive pin potentials, this one is the output is low. So there are the two types of comparator circuits, non-inverting comparators and inverting comparators. जैसे ही हमने op-amp में देखा था inverting op-amp and non-inverting op-amp. So now start with the non-inverting comparators. So the basic non-inverting comparators, you can see the figures is similar of the op-amp circuits. So in these comparators the input voltage is applied to the non-inverting terminals and so voltage is applied to the non-inverting terminals and no reference voltage is applied to the other terminal. So inverting terminal is grounded. So basically comparator is referred to the V reference is equal to 0. Here the input voltage is denoted by the VE, while the voltage is applied to the normal terminal voltage, which the Vn is compared is denoted as a V reference. So in the non-inverting comparators, if the V in is greater than the V refers, the output is V पॉजिटिव V स्टेट इज़ ऑलमोस्ट इक्वल टू द VCC, यानी कि जो इनपुट वैल्यूज़ V रेफरेंस करता ज़्यादा होगी तो हमको आउटपुट हाई मिलेगा, जो वोल्टेज जो हम इनपुट वोल्टेज 5 वोल्ट्स देते हैं उतना मिलेगा, इट मीन्स दी हाई. इफ़ द V in is less than the V reference, so the output is negative V state, so almost is equal to the 0, यानी कि V डबल ई में हम जनरली 0 देते हैं वो. While V in is less than the V reference, the output is negative. Okay, now this is because and the open loop gain is very higher even for the very small in the V in, the op-amp output is saturated, so that the input and output waveform for the basic non-inverting components, you can see the sinusoidal waveforms input. So by applying the any voltage other than the 0 to the inverting inputs terminals, the tripping of the component can be changed as per requirement, and in such a case the V ins compared with the reference voltage V refers applied to the inverting terminals. So these are the another figures for the basic non inverting comparator. अब ये जो है वो जो हमारी जो बेसिक सर्किट है, ठीक है, ये जो बेसिक सर्किट है उसका वेवफॉर्म है कि अगर V in is greater than the V refers, so the this only positive part is given the output, and V in is less than the V refers, the negative part will be open. So in similar way the input and output waveform for the positive reference, so V refers is given to the 1 volt. अगर V reference की वैल्यूज हम 1 सेट करते हैं तो they have only cut out these portions and we get the output in positive. इन सिमिलर वे नेगेटिव में अगर हम V रेफरेंस में जो वैल्यू पुटअप किया है वो 1 वोल्ट है तो नेगेटिव में मिलेगा. सो दीज आर द बेसिक non-inverting comparators. Now the inverting comparators, you can see the figures of inverting comparators in similar way. Which one is figure in the non-inverting? We can given the negative part input terminals give to the V reference is equal to 0. Here in similar way we can given the positive input terminals V refers is 0. So apply to the non-inverting input and the signal voltage is applied to the inverting input of the op-amp. So the V reference equal to V0 if the non-inverting terminal is grounded, when V in is less than the V refers. In similar mathematical summarized, so V in is less than the V referred, the exactly opposite to the non-inverting comparators. So positive output is positive V state almost equal to VCC, and if the V in is greater than V referred, so V0 is equal to negative V state is almost equal to the minus VE in. So the V refers can be set other than the 0 by using the battery and the potential dividers as per the requirements. So you can see the figures of the positive and negative output voltage. So these are the concept of the inverting and non-inverting comparators. So now what is the drawback of the op-amp comparators? So in the comparators feedback is not used and the open gain of the op-amp is very large, hence the very small noise voltage can be caused the triggering of the comparators. So the first one is this op-amp comparator circuit is typically used in the applications where the low performance is acceptable. So the practically due to the slew rate of limitations, the output take a finite time to switch from one voltage to the another level. Thus the output is destroyed due to the finite transient time. यहाँ पे क्या होता है कि हमने जैसे ही देखा कि जो वैल्यूज हम सेट करते हैं भी रिफर्स में वो टाइम कट ऑफ हो जाता है. So these are the very disadvantage. So the op-amp take a more time to recover from saturations as these are the designed to operate in a linear mode with the negative feedback. The another one is, and the external hysteresis is always required for the slow moving input, and the op-amp doesn't have any internal hysteresis. So in the comparator there will be diode connected back to back between the input of any op-amp, and that may cause the unpredictable current in the input. So these are the main 4 reasons the drawback of the op-amp comparators. Now what is the characteristic of the comparator? The first one is accuracy. So it is the smallest amount of the difference voltage required at the input of the comparator to make the output changes it stable. यानी कि अगर हम इनपुट चेंज करते हैं तो आउटपुट भी चेंज होगा बट स्टेबल रहते हैं. So it measure in the milliwatt. So the accuracy of the comparator depends on the voltage gain, common mode rejection ratio, input offset and thermal drifts. The next is the logic threshold. So it is the voltage level at the output of the comparator at which the connected digital device changing its state. For the TTL, if I given the approximately 1.2 volt, and for the Siemens A it is 2.5 volts. Then after the strobe functions, so strobe functions is the certain comparators are equipped with the strobe control input to enable and disable the device. When the comparator is enabled, the output will respond to the signal at the input, and when the disabled, the output will not respond to the input signals. This feature is used for the device selections in which the wired or the multiple comparators structures. अगर हम एक से ज़्यादा कंपैरेटर यूज़ करते हैं तो कौन सी सर्किट को ऑपरेट करना है उसके लिए हम स्ट्रॉब फंक्शंस यूज़ करते हैं. सो स्ट्रॉब फंक्शन इज नथिंग बट द इनेबल एंड द डिसेबल ऑफ द कंपैरेटर्स. देन आफ्टर द रिस्पॉन्स टाइम, so the speed of the voltage comparator is expressed by the means of the response time, and it is the defined as the time between the applied of the step voltage of predetermined the characteristic at the input and the instant at which the output cross to cause the output voltage to switch the state. यानी कि रिस्पॉन्स अगर हम कोई भी इनपुट देते हैं उसके बाद कितना टाइम ड्यूरेशंस लेता है वो उसको एग्जीक्यूट करने के लिए, तो दिस आर कॉल्ड द रिस्पॉन्स टाइम. देन आफ्टर द पॉजिटिव आउटपुट लेवल्स, सो इट इज़ द नथिंग बट द नेगेटिव डीसी आउटपुट वोल्टेज विथ द कंपैरेटर्स सैचुरेटेड बाय द डिफरेंट इनपुट इक्वल टू ग्रेटर देन द स्पेसिफिक वोल्टेज. Then after the negative level, it is the negative DC output voltage with the comparators saturated by the different inputs. Then the strobe current, so it is the define the current flowing out of the strobe terminals when it is at the zero logic level. Then after the strobe release time, it is the nothing but the time required for the output to rise to the logic threshold voltage after the strobe terminal has been driven from the 0 to the logic 1 level. अगर जो लॉजिक चेंज करते हैं तो कितना टाइम लगता है वो रिप्रेजेंट करता है. देन आफ्टर द सैचुरेशन वोल्टेज, द सैचुरेशन वोल्टेज इज द लो आउटपुट वोल्टेज लेवल with the input device equal to the other greater than the specific value. And last one is latching. The some comparators have the built in the latching facilities upon the receiving the active signal at the latch pin, the current output state of this comparator is frozen in the latch flip-flop and it is held identified until the arrival of the new latch command. So this latching is using of the flip-flops. So now the applications of the comparators. So there are the various applications of the comparators are here. So first one is the zero crossing detectors, then window detectors, level detectors and duty cycle controllers, and the last one is the pulse generators. Here you can only explain the few applications of the comparators. Now start with the first one, the zero crossing detectors. So in similar way, zero crossing detector is, there are the two main things, non-inverting zero crossing detectors and the inverting zero crossing detectors. Now start with the non-inverting zero crossing detectors. So applications detectors. So these detectors is the op-amp is used in the open loop mode, and inverting terminals of the op-amp is grounded and the input applied to the non-inverting terminals. So during the positive half cycles, okay, these are the non-inverting zero crossing detectors. Now during the positive half cycles, the input voltage is positive above the reference voltage and hence the output voltage is V state. These are the systems. So during the negative half cycles, the input voltage V in is negative, that is below the reference voltage, the output voltage is minus state. So these are the sinusoidals when the input is sinusoidal and when the input is triangular forms. Now the next topic is the inverting zero crossing detectors. So in the inverting zero crossing detectors, the input is directly applied the inverting input terminal while the non-inverting terminal is grounded. So during the positive half cycles, the inverting terminal is more positive than the non-inverting terminal, so the output is negative states. While the negative half cycles, the output is positive state. This circuit is called the inverters. So in similar way, the sinusoidals and the non-input and the triangular output inputs. Now the next detector is the level detectors. So level detector is nothing but the voltage level detector. One of the op-amp input terminal is based to the input voltage level which is to be detected, and the non-inverting is based on the V level, so that the which drop across the R2 and can be set the level to be detected. अब हम क्या करते हैं कि V लेवल को R2 में एक पॉइंट पे सेट कर देंगे और उसके हिसाब से हमको आउटपुट मिलेगा. तो यू कैन सी दैट द सिमिलर वे ऑफ द V स्टेट्स. हम यहाँ पे क्या करते हैं कि V लेवल को सेट कर दिए है तो उसी टाइप से हमको आउटपुट मिलेगा. तो दिस आर दी लेवल डिटेक्टर के एक लेवल हमने V लेवल सेट किया है, उसकी वैल्यू हम सेट करेंगे टू यूजिंग ऑफ द वेरिएबल रेजिस्टेंस ऑफ R2 और उसके हिसाब से हमको आउटपुट मिलेगा. नाउ द नेक्स्ट वन इज द विंडो डिटेक्टर्स. So window detector circuit detects when the unknown voltage falls within a specific voltage band or window, and it is also called the window comparators. So these are the circuits. So it consists of the two comparators and the two reference voltage VTL and VTH, lower and highs. So define the lower and upper limits of the windows अभी हमने लेवल डिटेक्टर्स में क्या किया है, एक लेवल डिटेक्ट किया है। अब यहाँ पे हम सिन्यूसॉइडल्स में अपर लेवल और अंडर लेवल्स को हम सेट करते हैं। सो TH इज़ दी अपर लेवल्स एंड TL इज़ दी अंडर लेवल्स, और उसके हिसाब से हमको आउटपुट मिलता है। सो व्हेन VI इज़ विथिन द रेंज, so VTL is less than the VI and less than the VTH, so the output transistor of the both the components are of the RC, depends on the RCs. So these are the window detectors. So you can easily identify what is the difference between the level detector and the window detector. level detector में हम R2 से एक पॉजिटिव पॉइंट सेट करते हैं और उसके हिसाब से हमको आउटपुट मिलता है। जब विंडोज़ डिटेक्टर उसका एडवांस वर्जन है, उसमें हम दो कंपैरेटर यूज़ करते हैं। एक से हम अपर लिमिट सेट करते हैं और दूसरे से हम लोअर लिमिट सेट करते हैं, और उसकी कंट्रोल करने के लिए हम RC रजिस्टर यूज़ करते हैं। सो दिस आर दी विंडो डिटेक्टर्स एंड द लास्ट वन इज़ पल्स जनरेटर्स. So pulse generators, you can see the figures, the comparators and the differentiators. So it converts the sine wave into the train of the pulse wave. So the circuit is implemented using the non-inverting comparators as a zero crossing detectors and the RC network and the series diode. So the output of the zero crossing detector is different by the RC networks and giving the positive and negative pulse. The diode connected in the series clip off the negative pulse and only the positive pulse appears in the final output. So you can see the output. So it is the important note that the frequency of the pulse waveform at the output is same as of the input sine wave. So these are the generating of the pulse. So today we can see that what is the comparators, what is the applications of the comparators and characteristics of the comparators. If any questions regarding this topic, you can call me. If any query regarding this topic, you can mail me. My mail ID and the contact number is in your screen. Thank you.